Hello dear students, this is the second lecture from the subject electrical circuits from the chapter single phase AC series circuits. In our first lecture we have discussed about the generation of alternating voltage, their waveform and some parameters, that is waveform, frequency, RMS value, impedance, reactance and phasor representation. So that we have discussed in the our first lecture with their respective formulas. Now we will discuss about the mathematical representation of phasor. Now phasor is whatever alternating voltage we generate with the help of an alternator, the magnitude of that voltage we represent in the form of graph, that is called as a waveform, and that magnitude also we can represent with the help of phasors. That phasors, the mathematical representation we will see in this content. Now consider the following phasor. In this phasor diagram, a voltage Vm make an angle phi with the x-axis. The magnitude of this phasor Vm is represented by a letter R, and on x-axis the value of x is calculated by x is equal to Vm cos phi, and on y-axis the value of y is calculated as Vm sin phi. Now this phasor is represented in two forms. The first form is polar representation. Now whatever phasor diagram we are watching on the screen, it is represented with the help of polar form as phi of t is equal to r at an angle phi, where r represents the maximum value of that quantity and phi represents the phase angle. For example, you will understand very well. If phi of t is equal to 100 sin 50 pi t plus 50 degree. Now this is mathematical equation of a voltage. Now this equation can be represented in polar form as phi of t is equal to 100 at an angle 50 degree. On the screen there is some correction, please note down. If phi of t is equal to 100 sin 50 pi t plus 50 degree, then the polar representation will be as phi of t is equal to 100 at an angle 50 degree, where 100 is a maximum value of voltage, that is Vm, and phi is a phase angle, that is of 50 degree. Now the same phasor diagram can be represented in another form called as rectangular form. In rectangular form, this phasor can be represented as phi of t is equal to x plus jy, where x is equal to phi m cos phi and y is equal to phi m sin phi. Now the final equation in the rectangular form for phi of t is equal to phi m cos phi plus j phi m sin phi. Now with the help of one example we will understand this. The above same example we will take if phi of t is equal to 100 sin 50 pi t plus 50 degree. Now that we have to convert or we have to represent in the rectangular form as phi of t is equal to 100 cos 50 degree plus j 100 sin 50 degree. Now we will see the conversion of polar form into rectangular form. If the polar form is given as phi of t is equal to r at an angle phi, then it is converted into rectangular form as phi of t is equal to r cos phi plus j r sin phi, where the value of r and phi are directly taken from the polar form. The conversion is one of the important part from this chapter, so please understand it carefully. Now we will go for the conversion from rectangular form to polar form. Now consider the rectangular form phi of t is equal to x plus j y. Then this rectangular form can be converted into polar form as phi of t is equal to r at an angle phi, where r is equal to or r calculated as under root x square plus y square, where the value of x and y directly taken from the rectangular form, and phi is calculated as tan inverse of y upon x. This conversion is also important. Now while solving the problems or while solving a circuit, to find the solution of a circuit we need a mathematical operation. Now we will see an addition and a subtraction of these phasors. Now consider a phasor phi1 is equal to r1 cos phi 1, and now consider a phasor phi1 is equal to r1 cos phi 1 plus r1 sin phi 1, that is x1 plus j y1, and a second phasor phi2 is equal to r2 cos phi 2 plus r2 sin phi 2 into j is equal to x2 plus j y2. Now the addition of these two phasors is done as phi1 plus phi2 is equal to x1 plus jy1, this is v1, and x2 plus jy2, this is v2. Now on the next step we add x1 plus x2, that is active part, plus, and in another bracket, j y1 plus y2. Now similarly the subtraction of these two phasors is done as x1 plus jy1, this is v1, minus x2 plus jy2, this is v2, and the final subtraction is x1 minus x2 plus j into bracket y1 minus y2. Now the important point to note in this addition and subtraction is that the phasors which is given should be in the rectangular form for the addition and subtraction. If the phasor is given in polar form, then it should be converted first into rectangular form, and then the operation of addition and subtraction should be done. Now we will go for multiplication and division of phasors. Now consider two phasors. Phi1 is equal to r1 at an angle phi 1 and phi2 is equal to r2 at an angle phi 2. Now the multiplication of phi1 and phi2 is calculated as phi1 into phi2 is equal to r1 at an angle phi 1, that is phi1, into r2 at an angle phi 2, that is phi2, and the final multiplication is r1 into r2 at an angle phi 1 plus phi 2. In this multiplication, the multiplication of magnitude of r is only done and the angles are added in the multiplication. Now we will see the division phi1 upon phi2 that is equal to r1 at an angle phi 1, this is phi1, divided by r2 at an angle phi 2, this is phi2. The final answer is r1 upon r2, this is only division of magnitude of r1 at an angle phi 1 minus phi 2, thus that is subtraction of phase angles. Now in the multiplication and division, 2 points should be noted, that in multiplication the multiplication of magnitude of r is done and phase angles should be added, and in division the division of magnitude of r is done and subtraction of angle is calculated, and the phasors which are given, that should be in the polar form. If it is given into rectangular form, then first we have to convert that phasors into polar form, and then we will go to multiplication and division by using these formulas. This way the algebra, that is addition, subtraction, multiplication and division of phasors, is most important point to solve any phasor or to solve any electrical circuit in this chapter. Now, whatever theory part was there about and generation of alternating voltage that we have seen. Now we will go for the numericals. Now consider first numerical as convert Z is equal to 6 plus 8j ohm in polar form. Now as we have seen that Z is the impedance and the value of Z is given as 6 plus 8j ohm, and that value of Z is in the rectangular form that we have to convert into polar form. The solution form for this numerical is the rectangular form is given Z is equal to 6 plus 8j, and the polar form of this equation is as Z is equal to R at an angle phi. Now the value of R is calculated as square root of x square plus y square, that is R is equal to under root square of 6 plus 8 square, that is equal to 10, and phi is calculated as tan inverse of y by x, that is tan inverse of 8 by 6, and that is equal to 53 upon 13 degree. Now the final answer or polar form of Z is equal to 6 plus 8j is Z is equal to 10 at an angle 53.13 degree ohm. The conversion is very simple but most important while solving the problems. Now we will see one more example related to this point. Now convert Z is equal to 16 plus 8j ohm in polar form. Now the polar form for this equation is R at an angle phi. We have to calculate R and phi. The value of R is calculated as under root x square plus y square, that is under root 16 square plus 8 square, that is equal to 17.89, and phi is calculated as tan inverse of y upon x, that is tan inverse of 8 by 16, and that is equal to 26.57. The final polar form of the given equation is Z is equal to 17.89 at an angle 26.57 degree. Now consider one more example. In this we have to convert a polar form to rectangular form. The value of Z is given as Z is equal to 10 at an angle 60 degree. This we have to convert into a rectangular form. Now the rectangular form for this equation is Z is equal to x plus jy, where we calculate x as phi or r cos phi and y is calculated as r sin phi. Now the value of R is 10 and the value of phi is 60 given in the equation. Now directly we put the values and find the equation for Z as 10 cos 60 plus j 10 sin 60, and the final answer for this equation is Z is equal to 5 plus 8.66 j ohm. Now we will go for one more example which is related to the waveform. Now find the frequency and RMS value of voltage from the waveform given in the following picture. Now whatever waveform we are watching on the screen has shown the magnitude of voltage, that is Vm is equal to 50 volt, and the time period, that is time taken by the waveform to complete one cycle, is taken as 5 seconds, that is t is equal to 5 seconds. Now to find the RMS value of voltage, we use the formula Vrms is equal to Vm upon root 2. The value of Vm is 50, that is 50 upon root 2, and the answer comes 35.35. And to calculate the frequency, the formula which we use is F is equal to 1 upon t, and the value of t is given as 5 seconds. Now F is equal to 1 upon t, that is equal to 1 upon 5, and the answer comes 0.2 Hertz. Now see, the very simple formulas are there, only we have to put the values and do the calculation. Now we will see one more same example. Calculate frequency, RMS value, that is root mean square value, average value, and amplitude of the waveform shown in the following figure. Now this is also a sine wave in which the value of magnitude is shown 100 volts and t, that is time period, is given as 20 milliseconds. Now we will go for solution. Now from the given waveform, Vm is given as 100 volts and time period is given as 20 milliseconds. Now first we will calculate frequency as F is equal to 1 upon t, that is 1 upon 20 into 10 raised to minus 3. Minus 3 is taken for milli and the answer comes as 50 Hertz. Now we will calculate second parameter, that is RMS value. Now Vrms is equal to Vm upon root 2, that is 100 upon root 2, and the answer comes 70.71 volt. Now we will calculate a third average value. V average is equal to 2 Vm upon pi, that is equal to 2 into 100 into pi, and the answer comes 63.6 volt. Now we calculate the fourth parameter, that is amplitude, that is maximum value, and is given in the waveform directly. Vm is equal to 100 volt. Now we will go for one more example. Voltage and current in a circuit with 50 Hz supply are represented as V is equal to 282 sin omega t and I is equal to 14.1 sin omega t minus pi by 6. Now we have to calculate RMS value of current, then average value of voltage and power consumed in the circuit. Now we will go for the solution. From the numerical, the given values are Vm is equal to 282, pi is equal to minus pi by 6, Im is equal to 14.1 ampere. Now first we will calculate IRMS by using formula Im upon root 2 is equal to 14.1 upon root 2 and the answer comes 9.96 ampere. Now we calculate V average is equal to 0.637 Vm. The formula for average value is V average is equal to 0.637 Vm, that is equal to 0.637 into 282 and the answer comes 179.6 volt. Now the third parameter we will calculate, that is power. The formula for power is P is equal to Vrms into Irms into cos phi. Now the value of Vrms is taken as 282 upon root 2. Irms already we have calculated in the first, that is equal to 9.96 and the value of phi is given pi by 6. Now after multiplication the answer comes, that is 1721.36 watt. Now we have seen some basic and important numericals from the contents which already we have discussed. Now for homework, take this example and you have to calculate the RMS value, amplitude and frequency of the waveform from this figure. Now we have one more example. Convert the following quantities, that is Z is equal to 10 at an angle 40 degree ohm in rectangular form and Z is equal to 8 plus 12J ohm in polar form. First quantity we have to convert, you have to convert in rectangular form, and second quantity you have to convert it into polar form. So already we have discussed some formulas in this video. Please go through this and try to solve this example as a homework. If you are having some confusion, some queries about this video, then ask in comments. And thank you for watching this video. Thank you.